Place a hot object in a freezing environment, and the thermal energy begins to migrate. It flows from the hotter system to the colder surroundings until both reach the exact same temperature. This is the baseline rule of thermodynamics. But while we can observe the results of this cooling, the mechanics of the movement are less obvious. How does thermal energy actually cross the physical space separating two objects? Energy has several distinct ways to travel. The specific route it takes depends on the environment it encounters, specifically the state of matter it must move through. Heat moves through direct physical contact, rides along with fluid currents, or leaps across empty space as invisible waves of light. Mastering these three specific mechanisms is how we engineer everything from simple cookware to the cooling systems preventing a nuclear reactor core from overheating. We can isolate these mechanisms using a standard physical setup: a campfire heating a suspended metal rod and a pot of water. Hold one end in the flames, and the other eventually becomes too hot. This is conduction. Conduction transfers heat between adjacent parts of a body because of a temperature difference. While the energy moves, the metal itself stays stationary. No matter actually flows from the fire to your hand. At the microscopic level, the atoms at the hot end of the rod gain kinetic energy and vibrate intensely. They begin bumping into their neighbors, passing that kinetic energy down the line through a series of physical collisions. The speed of this process depends on a material's thermal conductivity. Metals like copper and steel are efficient conductors. Materials with loose or pocketed structures, like wood or trapped air, are poor at passing energy along, making them effective insulators. Relying on atoms locked in close proximity to strike one another, conduction is the dominant mode of heat transfer in dense, solid objects. Now look at the water inside the pot and the air swirling above the flames. Heat moves through these spaces via conduction. Unlike the stationary atoms in our solid rod, this mechanism requires the actual bulk motion of matter. Because of this, convection is restricted exclusively to fluids, which includes both liquids and gases. Water at the bottom of the pot absorbs heat, expands, and becomes less dense, forcing it upward. As hot fluid rises, heavier cold fluid sinks to replace it. This fluid then heats up and rises, creating a continuous convective loop. These massive convection cycles drive global weather. During the day, warm air over the ground rises, and cooler air from the ocean sweeps in to fill the space, creating coastal sea breezes. Convection is a method of distributing heat energy by physically transporting the hot matter itself. But you can feel the warmth of a fire, even if you aren't touching a solid conductor or standing in the path of rising air. This energy is crossing the empty space directly via radiation. Radiation functions differently than the previous two mechanisms. It requires no physical transport medium, no colliding atoms, and no flowing fluids. Radiant thermal energy travels as electromagnetic waves. These are oscillations of electric and magnetic fields that move through space at the speed of light. When these waves strike a body, they are partly reflected and partly absorbed. Darker surfaces absorb this radiant energy much more effectively than lighter ones. We see this at the largest possible scale with the sun. Its heat reaches Earth by traveling millions of miles through an empty, freezing vacuum. Because it functions independently of physical matter, radiation allows thermal energy to cross the void of space. When we observe the entire campfire environment, we see a complete system with all three mechanisms operating simultaneously. The physical state of the matter determines the pathway. In the tightly packed atomic structures of solids, thermal energy travels by conduction. In liquids and gases, the energy is carried by the bulk movement of the fluid itself through convection. And across empty space, hot bodies emit electromagnetic waves, transferring energy directly through radiation. Heat transfer is a dynamic response to the environment. Solids conduct, fluids convect, and hot bodies radiate.